Alright, hello, my name is Jason Yao from Cluster 3, and today I'll be talking about electric cars. I'll be giving you a brief history, a few of its main components, and some of the problems that it currently has. So first is the question of, what are electric cars? So compared to our gasoline vehicle that we use today, instead of a gasoline engine we use an electric motor, which is basically the heart of the car. It also contains rechargeable batteries that store the power for the motor. Another main component is called the controller, and it connects the battery to the motor. It basically relays the power from it to the motor, and because there's no really moving parts, just wires, it can be classified as a wiring project. Another main component is called the potentiometer, and they come in a pair, and it basically connects the accelerator pedal to the controller, and basically tells how much power it's supposed to deliver to the motor. It's also a safety element because since it comes in a pair, the controller will see if they have the same reading, and if it doesn't, it just won't work. So now I'll be talking about the DC motor. It's a lot simpler and a lot cheaper than an AC motor and controller. It acts like an on and off switch, and the controller pulses the switch on and off. It also has the ability to go into overdrive. The AC motor and controller, however, is a little more complicated. It too pulses on and off, but it reverses the polarity of the voltage around 60 times per second. And however, it also has the ability to turn the motor into a generator when you brake. So the electric car was invented by Thomas Davenport and it began in the 19th century. However, it was non-rechargeable, so it was very inconvenient. However, it was actually very popular at its time. However, because it was non-rechargeable and other reasons, it came to its end. Other reasons was because the mass production of gasoline vehicles. Also, gasoline cars at the time were just much better. They're much cheaper, they have a longer range, and they're just more convenient for the people. But now today we see a sudden revival for these electric cars. This is 2000 Toyota Prius, one of the older versions of the electric cars that we have today. And there are many reasons why there's a sudden revival for electric cars. And one is being the increase of pollution. So gasoline vehicles take around 30% of the warming emissions that we have today. And 1 gallon of gas could equal around 24 pounds of carbon dioxide, leading to around 6 tons per vehicle annually. And of course, leads to global warming. Also, for electric cars, fuel is much cheaper and has better mileage. As gasoline is becoming less and less, gasoline prices go up. So that's a plus for electric cars. Also,
why drop you think? Why the price drop?
Because there's less gas. So
No. Look at the picture before that.
Oh, we can go back to that.
Okay.
But there's also a limited amount of fuel, so it's not renewable, so it will run out in approximately 50 years. Also, there are problems with, however, there are problems for the electric car. The normal lithium-ion battery is very heavy and really bulky. It weighs around half a ton, so that's really inconvenient. Also, electric cars are very expensive. Because of our current technology with batteries, batteries are very expensive, and also because electric cars are not that much high in demand, the market has to create such a high price for electric cars as well. Also, electric cars are very slow to charge. A typical battery takes around 6 to 8 hours to charge a whole battery, and compared to the few minutes for a gasoline car. Also, there are only a few charging stations around, so that's very inconvenient. Also, the battery has a very short life and capacity. A life of a lithium-ion battery could go to 3 to 4 years max, and it also could go around 50 miles per charge. So, again, very inconvenient. So with the technology that we have with electric cars, we could break into other types of vehicles, perhaps, such as solar panel cars. However, currently it's also very extremely expensive for a normal size car, and also it's very inefficient as it's usually a powerful car. And of course, it's only effective on sunny days. However, there are hydrogen fuel cell cars that also use electricity, which are much more promising because they solve the problems that electric car has with their batteries, because they're much more compact, light, and could almost instantaneously recharge. And so, in conclusion, electric cars are very fuel efficient. They're very eco-friendly, trying to solve the global warming problems that we have today. However, they do have problems with mainly their battery. So with the current technology we have with them, we can break into other types of vehicles. basically, sorry I didn't explain this good enough, but basically this chart shows the price for 27 miles. As you can see from like electric car, to drive 27 miles costs a little under $1. But for gasoline cars, it's now around $3.50. It just shows how much more efficient to the dollar it is.
Thank you.
You're welcome. Now I'll be talking about my mathematician and scientist, Danny Bernoulli and Claudius. I'll be giving a brief history of each figure and also a few of their main accomplishments. So first, I'll be talking about Danny Bernoulli. He was born on February 8, 1700 in Groningen, Netherlands. And he was born into a family of rather well-known and successful scientists. His father, Johann, was one of the early developers of calculus. However, Danny Bernoulli, even though he himself wanted to learn mathematics, his father wanted him to study medicine. But due to his determination, they struck a deal where he would study medicine and have his father teach him mathematics. So Bernoulli's accomplishments consist of his application of mathematics to mechanics. It was also his contribution to fluid mechanics. And he also did a great deal of work in conservation of energy. So one of his main accomplishments was the Bernoulli principle, and it basically relates to fluid dynamics. The significance is it shows a relationship between the fluid's components such as speed and pressure. And it can be represented by the Bernoulli equation. It states 1/2 rho v squared plus rho gh plus p is equal to constant, where rho is density, p is pressure, v is velocity, gravity, and gh is floor height. And it all equals a constant. So basically, this equation, as you can tell, it exemplifies conservation of energy, similar to the mechanical conservation of energy of 1/2 mv squared plus mgh. And as you can see, it shows a relationship of different fluid components such as kinetic energy and pressure. So if you see, based on the equation, the higher velocity and kinetic energy of the fluid, the lower the pressure, and vice versa. The lower the velocity and kinetic energy of the fluid, it results in higher pressure. So this principle can be related to this easy example of two ping-pong balls hailing from the ceiling. If you blow air between the two, the air's velocity will go much higher, leading to the pressure to go lower. And the two ping-pong balls would go closer to one another. This could be also applied to wings in airplanes. As you know, the air above the wing is much faster, leading to lower pressure, so that creates split for the plane. So in conclusion, for Bernoulli, he was fortunate to be in an environment full of very bright family members, and then that and his hard work allowed him to work greatly in the field of conservation of energy and fluid mechanics, and leading to the Bernoulli principle and equation. So next, I'll be talking about Claudius. He was born in Kozlin in Georgia. He studied math, physics, and even a little history in his time. And just fun fact, he took part in the Franco-Prussian War. Claudius' accomplishments consisted of him finding the second law of thermodynamics. He was also considered one of the central fathers of thermodynamics. And he also made known the theory and idea of entropy. So, the second law for thermodynamics was first introduced in his paper on the morning force of heat, and it basically states heat can never pass from a colder to warmer body without some other change connected therewith occurring at the same time. So basically, hot things transfer heat to cold things. And he also had the idea of entropy. And entropy is basically a measure of disorder within a system. It means content transformed to degree. And he also made his own unit for it called Claudius, but we don't use it today. And basically 1 calorie per degree Celsius. And entropy can be seen almost everywhere in life. It can be seen in a campfire burning to ashes, an ice turning liquid form water, even your room, because no matter how clean you try to have it, it will get messier each day. So applying entropy to thermodynamics, we know hot things naturally transfer heat to cold things, just like how ice naturally melts into a puddle. And because the liquid form of water is much more disordered than ice, entropy is therefore increased. So that is a form of a reversible process because liquid form of water could go back into ice. That does not produce a net change in entropy. However, there are irreversible processes like wood burning into ashes. That produces a net change in entropy, so entropy in the universe always increases. So in conclusion, Claudius was one of the leading figures in thermodynamics. He introduced the second law of thermodynamics, and he also introduced the idea of entropy. So, thank you.